My name is Sartaj student ID 20240953, and this is my STT500 statistics for decision making assignment. So the heading of this assignment is like statistical case scenario analysis. So in the first slide, we have the introduction. So in the introduction, we have purpose of the analysis, then use of a simple and multiple linear regression model to evaluate house prices. Then we have key variables, number of rooms and number of bathrooms. Then we have methods, graphic analysis, hypothesis testing, and regression analysis. So in this slide, we have the question one, geographical analysis. In this geographical analysis, we plotted house prices against the number of rooms and bathrooms. From these visuals, we observe a general upward trend in price as the number of rooms increase. Through there are some notable outliers. Similarly, price vary with the number of bathrooms. Through the trend isn't as pronounced. These visualizations provide an initial understanding of how these two factors influence prices and prepare us for deeper statistical analysis. Then we have question two, hypothesis testing. So we performed a two simple t-test for compare house prices between the north and south regions. The null hypothesis assume a significant difference between the regions with a p-value of 0.149, which exceeds of 0.05 significance level. We fail to reject all null hypothesis. This means there is insufficient evidence to conclude the house prices differ significantly between the north and south regions. Then next we have question three, simple linear regression. So we conduct a simple linear regression with the number of rooms as the independent variable and house prices is as the dependent variable. While the number of rooms is significant, the models are squared value is lower, then meaning it explains only a small portion of price variation. Uh, the negative suggestion to increase the number of rooms led a slight decrease in the home prices and unexpected results that could point to other influence factors. So next we have question four, model assumptions for simple linear regression. And to validate the simple linear regression model, we check its assumptions. The residential plot shows the relationship between the number of rooms and houses prices, maybe not perfectly linear. Additionally, the normal profitability plot suggests deviations from normality, and the residential spread shows a sign of scarcity. These violations means the model may not be entirely appropriate for the data set and may require transformation for additional variables. Then we are talking about question five, multiple linear regression model two. In model two, we use multiple linear regression to examine the influence of both of the number of rooms and bathrooms on house prices, while the number of rooms remains significant with the p-value below 0.05, indicating it's a substantial effect. That number of bathrooms does not show any significant contribution. This highlights that in this data set, the number of rooms is a more important predictor than the number of the bathrooms. The inclusion of addition variables has led to a slightly improvement in R squared compared to model one, but it is still quite low, showing that more factors may need to consider to better explain house price variations. Then we have question six, model assumptions for multiple linear regressions. In model two also encounters issue with assumption violations, much like model one. The residential plots reveal non-linear in the relationships between both number of rooms and bathrooms and house prices. In additional, the residential do not display a constant variance, indicating a violation of scarcity assumption. The normal profitability plot shows a clear deviation from normality. These violations suggest the model 2, although it incorporates more value, still struggles to meet the key of regression assumptions, which limits its effectiveness. The model may require transformation or additional variables for the better results in the future. Then we have model 1 versus model 2 comparison. So comparing model 1 to model 2 reveals that model 2 performs slightly better as indicated by the higher R squared value. However, the improvement in the minimal suggestion that additional the number of bathroom doesn't contribute much to explaining house prices variations. So model 1 is simpler and still identify uh, the number of room as the significant predictor, while model 2 incorporates more factor by struggling the key assumptions volations. In summary, neither model provides a strong fit for the data, highlighting the need of the future analysis for the inclusion of additional variables to capture more of the variance in the house prices. Then we have question 8, significance of independent variable in model 1. So in model 1, we tested the significance of the number of rooms as the independent variable with the p-value below 0.05. We are rejected the null hypothesis and conclude that the number of rooms significantly contributes to the model. This finding means that the number of rooms has been a measured effect on the house prices despite the model's low R squared value, indicating it explains only a small part of price variations. The number of rooms remains an important factor in determining house prices. This highlights the need of explore to other variables to improve the model's overall explanation power. So then we have again the significance of independent variables in model 2. In model 2, we tested the significance of both independent variables, the number of rooms and the number of bathrooms. While the number of rooms remains in the significant predictor, with the p-value below 0.05, the number of bathrooms does not show significance and its p-value exceeded 0.05. This means that within the data set, the number of rooms plays a far more crucial role in the determining house prices than the number of bathrooms. We rejected the null hypothesis for the number of rooms, but failed to reject it all the number of bathrooms, confirming that all variables contribute equally to the model. Then in last, we have the conclusion. To conclude both of the simple and multiple linear regressions, model reveals that the number of models in a significant predictor of house prices. However, both models explain only a small portion of the variability in price as reflected in their low R squared value. The inclusion of the number of bathrooms in the Model 2 did not significantly improve the model's performance. These findings suggest that other factors such as location or property size may be influencing house prices. Further analysis using additional variables for more advanced technologies and techniques may provide a more accurate model and helps address the conceptions violation observed in the analysis. So this is the end of the presentation. My name is Sartaj Singh, student ID 202400953, and this is my individual PPT for STT500. Thank you.